In these videos, we're going to talk about the role of pivots in reduced row echelon matrices. I'm going to start by considering a couple of examples. So when we look at this matrix, we have pivots here in the second and fourth column. So pivots in reduced row echelon matrices our leading entries equal to 1, they move to the right, and above and below them we have zeros. Okay. We have corresponding unknowns, and unknowns associated with pivots are called pivot variables. So here we have two pivot variables called B and D. Everything else is called a free variable. So here our free variables are A, C, and E. Okay, so a couple of quick observations. If we look at the system that a reduced row echelon matrix corresponds to, for example, this one is B plus 2C plus 5E equals 6, and D plus E equals 7, and 0 equals 0. You'll notice that because we had that our pivot variables are the only occur only in that one row, and all of the other entries in that column are equal to 0. What that means for us in our system is that the pivot variables occur only once in just one equation. What that means is that if we solve for those pivot variables, so in this case that would look like B equals 6 minus 2C minus 5E, what we see is that the pivot variables can be expressed as functions of things that are not pivot variables, of the free variables. Moreover, they're only going to be expressed as functions of the variables occurring to the right of them, because we have zeros to our left. And this is true no matter what reduced row echelon form matrix you're looking at. It's always true that pivot variables can be expressed as functions of the free variables to the right of our, this should be, say, of our pivot variable. So there's some connection between the pivot variable and the free variable, and it's expressed with this function. Notice that there aren't any other restrictions on the free variables. They don't appear as in any other way in these equations. And this is why they're called free. We can choose them to be any value we like. So in our case, our free variables are A, C, and E. So when we look at our solutions, we have our solutions are going to be elements of R5. So we have 5 different coordinates, and as long as I use these functions of my free variables, I'm going to have a solution to my system. So for B, I'm using the function 6 minus 2C minus 5E. C is free, so it can be anything. D needs to be 7 minus E, and E is free. So you can see that our free variables occur just as themselves in the solution set, while our pivots occur just as rewritings of the equations which contained that pivot variable. Okay, so we had a good question in class about why we would solve for pivot variables in terms of free variables instead of like maybe going the other way around. So which variables are pivot variables corresponds to our original ordering of like A should go first, and then B, and then C, and then D, and then E. If we had changed the order of the variables in our original system, we would have a matrix that looked a little bit different. So in some ways, there's nothing super special about B here. On the other hand, though, being a pivot variable gives us some advantages that make us prefer to use pivot variables once we're in reduced row echelon form. So our pivot variables occur in just one equation. So that means that this variable B cannot show up in any equations further down. So it's like really clear how B depends on C and E, and there's no other sort of hidden dependency. There are no other variables that affect this. In contrast, if, for example, we had decided to solve for E in this expression, we would get that E was equal to 7 minus D, and B is equal to 6 minus 2C minus 5E. So we could either have sort of two equations, or three equations here, where E is occurring in two of them. So B secretly also depends on D, so B is a function of C and D. Or we end up with sort of odd feeling things, like if we had solved for E, and then we would get E equals 6 minus 2C minus B over 5, and it's also equal to 7 minus D. This is a lot harder to understand than this first writing, where E and C can just be anything.